Thank you. I apologize. I woke up with a cough this morning and tried to get through this talk. But I'm going to talk about something that's a little bit closer to human time scales, earthquakes. Probably many people have experienced an earthquake, or if you haven't, you've certainly seen the news reports of large damaging earthquakes that have happened all over the world. And particularly the Tohoku earthquake that happened here 5 years ago is a huge event, and I want to spend some time giving you some of the details, what happened, some of the related disaster effects, and what we might do in the future to mitigate some of these effects. So the earthquake was on March 11th, 2011, magnitude 9.0, and it's the largest event that we have in the Japan historical catalog, which is over 1,000 years. Over 18,000 lives were killed. Economic losses, depending on how you count, are maybe around US $300 billion. If you were in Japan, and the Japanese know this really struck home, I think, to a lot of people, the scale of this disaster. One of my colleagues described it as, you know, if a few hundred people had gotten killed, people would have said seismology and geophysics is very advanced in Japan, and the mitigation and the recovery or the preparations are doing very well. If 1,000 people had gotten killed, they probably would have said, well, there's actually very good progress. An earthquake of this size would have killed many more people in other countries of the world. The fact that tens of thousands of people were killed in Japan, I think, was really a shock. Japanese seismologists, emergency response people were almost at a loss. So they've been working so hard over so many years. Why does a disaster of this size still happen in probably the best earthquake-prepared country in the world? And there's a lot of reasons, a lot of complicated reasons, and so I'll go through some of those now. This area has a lot of earthquakes, the Tohoku area. In the last 50 years, there's been 7 magnitude 7 and 2 magnitude 8. In the last 400 years, 13 magnitude 7, 5 magnitude 8. So very often, very large, very destructive earthquakes. And because of that, seismologists, I think, got a sort of false security that they thought they understood the activity here. You know, when you see so many large earthquakes repeating, then you think, you know, probably it'll continue with that type of activity. Probably we understand basically what's happening, and we can go and actually calculate probabilities. And so this was done to a very detailed. This whole area was divided up into sections, and probabilities for all these sections were calculated based on a lot of things: historical records, present-day plate rates, present-day observations. So, for example, this area off of Miyagi had a 90% chance of a magnitude 7.5 in the next 30 years. The area off of Fukushima was very low, about 7% in 30 years. And so there was very detailed studies, and people thought they had a pretty good handle on how often, how large, and the sequence of events that would happen here. So earthquake sources were expected to be around 50 to 150 kilometers in length, and that gives magnitude 7.5 to 8.2, and occurring at different intervals depending on the area you're in and the probability. Well, that didn't happen. What did happen was we got a magnitude 9 that broke essentially all of these sections together. So it was sort of a cascade type of event that started in one and then just continued through. And so the whole event just kept on growing. It didn't stop at these segment boundaries that people thought it would. And so it was a magnitude 9 or 9.1 earthquake, had a length of about 450 or 500 kilometers long, width of maybe 150 to 200 kilometers. So that was what was unexpected, the size. And magnitude 9 is much bigger than magnitude 8. If you know anything about magnitudes, they're logarithmic. So magnitude 9 is 10 times bigger than a magnitude 8, or 100 times bigger than a magnitude 7. So the fact that a magnitude 9 earthquake happened was just not a total surprise, but was certainly rather unexpected for this area where a magnitude 9 had not been seen over a history of about 1,000 years. This is sort of the earthquake cycle. You probably know about plate tectonics, where the Pacific plate is going down underneath the Japanese islands, and as it goes down, it drags the upper plate with it. And so over 100 years, 1,000 years, more and more strain is being accumulated until it reaches the breaking point and it suddenly snaps back. And that's what an earthquake is. It's just that snapping back of the upper plate. When it snaps back, obviously the ocean floor moves a lot. And so that's what causes the tsunami, just the deformation of the ocean floor. And the fact that it was a magnitude 9 meant the area was much bigger. The area of slip or the snapback was much bigger than anything that's ever been seen before. The slip was maybe 50 or 60 meters, which is really huge for an earthquake. And so those all contributed to this very large tsunami that was caused by the earthquake and essentially devastated the northeast coast. It's very easy to see the signs of tsunami. Here's a building near the coast, and you can see the first 3 stories, the windows and the verandas are all broken, and above that they're not. So the tsunami came at least up to here. And that's about 10 meters. It's probably 3 or 4 meters above sea level. So here the tsunami reached at least 15 meters. And 15 meters is pretty high. If you were to stand there, it's actually a little bit hard to conceive that the waves are coming in at that height. And that certainly wasn't the biggest place. So here's the tsunami survey, and all the way from about Fukushima to northern Miyagi, the wave heights were at least 10 meters over like 400 kilometers of coast. So a very large area was exposed to very large tsunamis. The highest run-ups are 30 to 40 meters, which again is just a huge, huge height for these tsunamis that came in. So it really was a tsunami that caused the damage, and it was really this unexpected size of the earthquake that caused the unexpected size of the tsunami that did so much damage in this earthquake. Okay, so just repeating the earthquake. Expected earthquakes were sort of magnitude 7 to 8, but the magnitude 9 happened, and because it was a magnitude 9, there was this 50 or 60 meter slip on the shallow portion of the fault, and that's what caused this really bad tsunami. So probably one of the most important lessons is that even an area with many earthquakes, 500 years is still too short. And 500 years seems like a long time in terms of seismology and a lot of earthquakes, but you need more time to see these rare events, and that's something that we heard before. You know, we want to think about, you know, these rare events and what we want to do. Are they going to happen again? What should we do to prepare for them? When we think about earthquakes, usually we think about the shaking. And usually it's the shaking that does the most damage in an earthquake. And it shook very, very hard in an earthquake. So these red areas have accelerations of about 1 G or over. And again, over about 400 or 500 kilometers. So again, a very large earthquake, a very large area was shaken very hard during this earthquake. These are velocities. Actually, in terms of buildings, they say the velocity is more effective than the acceleration in doing damage. But it's the same story that 400 or 500 kilometers of coastline was shaken very severely by the earthquake, and for a long time. A magnitude 9 has a duration of maybe about a minute, and it probably felt a lot longer than a minute if you were there in this earthquake. But the shaking damage was relatively small. The deaths from collapsed buildings and landslides was only about 4%, so less than 1,000 people. And if you could point to something positive from this event, this is one thing, that in general, the buildings did very well in Tohoku. This kind of shaking in any other country probably would have produced tens, if not hundreds of thousands of deaths at those kind of really intense shaking. And so if anything that we can say good about the earthquake or good about the preparation is that the building standards did relatively well and that not so many people were killed. And the reason, again, is simply because they have a lot of earthquakes there. Every time you get an earthquake, it essentially takes out all the bad buildings. And if you rebuild to a higher standard, then eventually you just improve the building stock. It's a kind of a natural selection process that happens there. We've heard a lot about the nuclear power plants. I don't want to spend too much time on there, but I just want to make one point, and that is the shaking damage. We don't know because there's nothing much left, but apparently it was not the shaking damage that destroyed or damaged the power plants. That they were designed for the shaking that happened and that the structures did perform well. The problem was that the power went out and a lot of the backup power supplies were close to the shore, and so the tsunamis took out the backup power supplies, and so the nuclear power plants overheated. And so that was an error in judgment, but it was not because of the shaking, which is what most people are really worried about in terms of the nuclear power plants. And just an example, there were 4 nuclear power plants along the coast. Fukushima Daiichi is the one that had the meltdown. Onagawa actually was closer and was shaken much more strongly, but did not have the same problem simply because they could return the power. The power did go out, but they were able to restore power, and so the cooling systems work. So just like to make the point that it wasn't because of the earthquake shaking that caused the disasters at the nuclear power plants. Okay, back to the tsunami. I always ask my students this question. You've seen a lot of video and the tsunami. So how fast do you think the tsunami comes? Do you think it comes at the speed of a car or the bullet train or jet airliner or seismic waves? And of course, this is important because we want to talk about the tsunami warnings. I won't ask you that question, but the answer is close to shore, where the water depths are shallow. They're traveling maybe 40 to 80 kilometers per hour, and maybe even more slowly in 5 or 10 meters of water. Offshore, 100 kilometers offshore, they're traveling 200 or 300 kilometers an hour. So if you see it coming, you still have a chance to get away if you can run very fast or if you have a bicycle or a car. And it's coming much faster offshore, but you can't see it at that point. But anyways, the point is that you do have, not a lot, but you do have a fair amount of time between when the earthquake happens and the tsunami arrives, especially if you have good information when the earthquake happens. And there was good information. So the tsunami warnings were issued at 1446, 3 minutes after the earthquake origin time. The initial magnitude was a little bit off, it was a little bit low, but there were updates sort of 10 or 15 minutes later that gave the correct magnitudes. So here's several sites, especially look at these where some of the bigger tsunamis came and the arrival times. So even at the closest one, I guess is this one, there was, I can't see, there was still 35 minutes, over half an hour. Here, 38 minutes, 43, 43, 68, over an hour. So even at the close sites, there was a fair amount of time if you had reacted very quickly to the tsunami warning to get away. And usually you don't have to go very far. Usually there's evacuation sites designated, and you just have to get, 40 or 50 meters up a hill or something to get away. If you're on flat land, it may be a little more difficult, but generally this amount of time should have been enough for most people to get away from the tsunami. So this is actually a big problem or a big issue. So the tsunamis were much larger than expected. They were over 30 meters in some places. And there's lots of tsunami gates and walls all over the area. But most of those are only about 10 to 15 meters. And those would have been okay if it was a magnitude 8 earthquake. But again, because this was much larger than expected, these tsunami gates were too low. I think I have a. Okay, so here's a picture of one. This is probably what, about 2 meters and a few meters above sea level. So this is probably about 9 meters or so here. And this is the site where you probably see a lot of photographs where they have of the tsunami coming over the top of the wall in Miyagi City. Some of those tsunami walls were actually broken by the force of them. But it's still a real issue, a real problem, why people did not leave faster. If everyone had dropped everything they were doing and immediately tried to get to higher ground, there probably would have been very few deaths. Half an hour, you can get pretty far, even at walking speed in half an hour. And it's very ironic because probably the Tohoku area is the best educated area in the world for tsunami hazards. They have a long history. In school, all the children are taught what to do. There's well-marked evacuation points. If you drive in the area, you see lots of signs. And so it's a real problem or real issue is, why didn't people just drop everything they do and go away? One possible explanation is that there was this false security from all these walls. And again, if you go there and you see these walls, they're pretty high. And it's kind of hard to imagine if you're standing there on a sunny day that the waves are going to come over the top. And so that probably worked against the situation at this particular one. Another thing that's kind of interesting is that 2 days before the earthquake, there was a foreshock, about 7.3. Still pretty big, still shook the area. Everyone felt it. A tsunami warning went out as usual. A tsunami came, but it was only about 40 centimeters high. And some people say that maybe that sort of caused some complacency, that people just a couple days before had experienced shaking, had seen the tsunami warnings, and saw a very small tsunami and figured that, well, we have the walls, and maybe that was, again, something that worked against them in the earthquake. Another thing is that the earthquake, the warning went out in 3 minutes, and that was sort of magnitude 7.9, but that warning was sort of, it's dangerous and you should leave, but then a much larger warning came out about 5 minutes later saying it's really dangerous, you should really leave fast. But probably most people just reacted or listened to the first warning. Also, the power went out very quickly, and so probably a lot of people didn't hear the second warning. So there's a lot of issues, a lot of complications, and those sociological reasons are being studied now. But again, it's just rather sad that this area really was very well prepared, but there were just sort of sequence of events that still caused that 15 or 18,000 people to be killed by the earthquake. Okay, so that's basically what I wanted to say. First lesson is that for geological hazards, 500 years is certainly not long enough. And we've been hearing that. Solar flares, floods, the 1,000-year flood, volcanoes that erupt every 10,000 years. Geological hazards are difficult to evaluate, and just because it's never occurred before does not mean it's not going to happen tomorrow. The technology of the warning system worked very well. The tsunami warnings went out within 3 minutes. I didn't talk about it. There's also an early warning system in operation, and that went out sort of within a few tens of seconds to Tokyo and other areas. So the technical warning systems in Japan are designed very, very well, very resilient, and worked very well and very fast. But again, it was sort of the response that caused the problem. And one thing we always say is building codes are probably one of the most effective ways to save lives. You know, don't try to expect the early warning or expect that you're going to get told of the earthquake beforehand, but just build your buildings strongly, and that certainly paid off for the Tohoku area. Just one last comment. So we've been hearing this several times. Professor Yamashiki mentioned it quite a few times. You know, what do we do for a rare or extreme event? I mean, probably another M9 is not going to happen in Japan in our lifetime, or even our children's lifetime. So how do we plan our education and hazard mitigation efforts that are going to span generations? We have to have lasting programs that don't depend on someone remembering what happened in the last earthquake. What are the practical strategies for rebuilding? We could build 30-meter walls along the coastline, but I don't think anyone would think that's a very reasonable type of solution. But these are the kind of problems that we really need to look at for the rare, you know, once every 1,000 or few thousand year event that is going to be very large, but we ourselves probably aren't going to see that. And I think that's a real challenge for especially the seismic and the volcanic hazard mitigation efforts. So I'll stop there.